Hello, everybody. My name is Long Lê. I'm sorry I cannot attend the conference, so I made the presentation. This is the joint work between me and my advisor, Professor Chiraksha, on retrieving rising star in the focus community question answering. Here is the outline of my presentation. It including background, problem definition, method, experiment result, summary, and future work. Let's go with the background. You may have a question. What is community question answering or CQA? CQA is a public venue where people can ask questions and share knowledge. Some popular CQA are Stack Overflow, Yahoo Answer, or Brandly. I guess majority of us here are computer scientists. You should be familiar with Stack Overflow. This is the focus CQA where all the question and answer must relate to programming. Yahoo Answer is the most popular CQA with billions of answers. The topic in Yahoo Answer can cover from any topic. Recently, CQA also popular in education and Brandly a front runner in CQA. Some of us might also ask, we already have a traditional search engine, Google search, Bing, Yahoo search. Why still need CQA? There are several reasons for it. The users are not satisfied with the search result, and they want more personalized answer. For example, you can go to online to ask opinion about some case. For example, I cannot get a visa or my visa declined. What should I do? The most important is collecting intelligence or wisdom of the crowd. The general idea is nobody knows everything, but everyone will know something. Some users will be expert in some field, so when you post the question in community, if they read your answer, they might help you, and you can expect this is a good answer, but you can get a crappy answer. They nothing warranty. Now, I will define the problem of the rising star. The rising star is defined as some new user, nothing special, but they will become the top contributor of the site in the future. But we want to predict it very early. This is the formal definition. Given a user with all of his posts in the first 3 weeks, will he become the top contributor of the site? Or given a user of his first 3 posts, will he become the top contributor of the site? Why this is an important problem? In previous study in WWW 2008 and Asunam in 2013, it is shown that a small number of users contribute majority content of the CQA. I also have a similar result later, and this rule is not only true in CQA, but it will be true in majority of online community. Even small number of users contribute to the content, but this content will generate the traffic of the site because majority of other users need to have a good content to visit up the site. And early recognition can encourage the user to contribute more. It is studied in WWW 2013. But predicting rising star in CQA is a very difficult problem. Rising star was studied in publication network or social network, in those cases, they have information of the peer, which are really critical. For example, in publication network, if you publish the paper in the top venue or you publish the paper with well-known scientists, you will have a higher chance to be success in the future. But the link in general CQA is not so strong. So in order to solve the problem, I propose a data mining solution in a PCTC. What PCTC stands for? It stands for personal, community, temporal, and consistent. In our data mining solution, I extract the feature. Then I build the training set by defining rising star. In the last step, I apply different classification, logistic regression, support vector machine, decision tree, random forest, and adaptive boosting to detect who is the rising star. So what is PCTC? It included personal feature. Personal feature record the history of the user, how many number of posts they made, what is the topic they participated, what is the average length of the post, and also the ratio between question and answer. The community features record how community feedback to the user action. For example, the average score, the average comment, or the average favorite mark. And temporal feature including every gap between the posts, what is the duration of the two recent posts, and the trendings of the posts. The consistent feature including standard time gap between the posts, the standard score between the posts, and standard time gap between the posts in the second half of the observation period. And we also record whether they are more active or less active. We call it active trending. Any classifier can apply to our model. In our study, I applied some popular classification. Logistic regression, it is a generalized linear model using the sigmoid function. In the first step, we apply the regression to estimate some regression parameter and put it in the sigmoid function to have a positive or negative value. A support vector machine with RPF kernel. The RPF kernel is defined in this formula. If the value x and x prime is very similar, the kernel equal to 1. Otherwise, the value of the kernel equal to 0. Decision tree is a tree-based method. This is a non-linear model that participate the feature into smaller set and fit simple model. The tree will stop until it reaches some depth or some limit some number of the node in one branch. Random forest is a back-in method. We use a bag of 100 trees, and given a sample set, the random forest will randomly select some data set and randomly select some feature. This step also select a subset of feature, and when we have a new value, we use the majority voting by those decision tree. A random forest is a good node for avoiding bias. Furthermore, because random forest trees are built separately, so we can compute it in distributed way. But in most of the problem, we don't need to apply distributed computation. The last method is adaptive boosting. In adaptive boosting, we use a list of weak classifier to obtain stronger classification by performing adaptive sampling. We will put the higher weight or difficult example. Now I will discuss about experiment. I use the Stack Overflow from July 2008 until September 2014 with 3.4 million of users. Those users given 21 million posts. In Stack Overflow, they represent the reputation of the user by the score. Here is the table how score is computed. If you give a good answer and your answer is upvoted, you will get 10 points. And if you give a bad answer or bad question, they will downvote. In some case, you really need to have an answer. You can give it some penalty. And if somebody can answer your question, they will get the penalty value. And if you give some spam, the site will deduct you a lot of points. Now I will analyze some characteristics of the data. Oh, sorry. So let's discuss about the data processing first. Most of the users are inactive. So I only consider the user who stay more than 1 year. This will give me a set of nearly 400,000 of users. So given this user with the first T-width or T-post, we try to predict whether they become the rising star. And how to divide the rising star? In publication network, they can yield how many citations, whether the author will become full professor in the top university, or whether they will become the IEEE or ACM fellow. In CQA, I yield the score they earn in the future. And it is not fair to compare a new user and the user stay for a long period. So I compare the score they earn after fixed period. So 1 year. Here is the data analysis. In this diagram, I plot the user activity. In the x-axis is the number of answers given by the user and the y-axis is the number of users. Remember the plot in log scale. We see that a lot 10,000 users give a one post, but some users give a 1,000 posts or even 10,000 posts. It follows exactly the power law. We see that a very small number of users give an extremely high number of posts. In this diagram, I see whether there is any correlation between the score and the length of the post. I bind the length of the question and compute the average score. This is the average length of the post, less than 20 words, more than 480 words. And this is the y-axis is the average. It's very surprising that there is no difference between the average score compared with the average length. The reason in Stack Overflow, many short answers receive high score because the answer is really brilliant and it attracts a lot of upvote. Later, we see that the average length will be very good indicator to the future performance of the user. The reason is the user who spend a lot of time to write the long answer at the beginning tend to contribute more. They have a greater attachment to the site. This diagram examines the effect of the number of posts. The x-axis is the number of posts and the y-axis is the score they earn. We see that the higher number of posts, the higher score they earn, but this is not linear. And what about the quality of the post? We have a normal user, top 10% user, and top 1% user. And what is the score they earn after 5, 10, 15, or 20 posts? We see that The top 1% user have a tendency to perform better at the beginning. And I examine percentage of the answer in the total number of posts. We see that the top contributor normally have a majority of the posts are answered. Now about the result. I compare my method with ARIMA. This is an general time series analysis. It including autoregression, integration, and moving average. And random, we just get the user randomly. And we try to predict whether the user will become the top 1% or top 10%. Top 1% may be considered very distinguished user. Top 10% may be considered very good contributor. Here is the accuracy. The y-axis is the accuracy, so higher is better. In the left diagram, this is the observation duration. We observe after 1 week, 2 week, 3 week, 4 week, and predict whether they become the top contributor after 1 year. And in the right is similar, but we observe the first 5 posts, 10 posts, 15 posts, and 20 posts. Our method can achieve very high accuracy from 80 to 90%. This is for the top 1%. And the result here for the top 10%. We see that predicting the top 1% in achieve higher accuracy because the top 1% is more distinguished compared with other users. I also compare the accuracy between classifier. If you take a look at the table, the random forest and adaptive boosting achieve high accuracy compared with other methods. But in general, our framework don't fluctuate a lot. In this slide, I measure which feature is important in predicting. So higher value is more important in predicting. We see that the number of posts, the average length, the average score, the average gap, and an average gap in the second half of the period in observation have a high prediction value. And we also try to see whether our method can work in smaller community. We try to sample 50%, 20%, 10%, 5%. In general, our method still perform well, but when the community is smaller, the accuracy declines a little bit. So in the summary, we show that it is possible to identify rising star in the early stage, and we also determine which feature is more important in predicting the future performance. And we expect that our work can have the community side to have a suitable action. The limitation is we could not see the effect if we give some incentive to the user. Thank you for listening, and feel free to contact me at this email address and my personal website. Again, I'm really sorry I cannot be here to present, and enjoy the conference. Enjoy Danang. Thank you. Bye-bye.